find the PMF of that random variable x. So PMF of random variable x taking values 1, which is by definition probability that x takes exactly value 1, which is, because it's a binomial random variable, it is 3, 1, p to the 1, 1 minus p to the 3 minus 1. So it is going to be 3, and then p is 1 half, and then 1 minus p is 1 half, and then 3 minus 1 is 2. So again, it is going to be 3 over 8. I'm going to give you a complete solution of this, not going to write dot dot dot. I'm going to go through all the solutions. So PMF of random variable x taking value 2 is, by definition, it is probability that x takes value exactly 2, which is 3, 2, p to the 2, p squared, 1 minus p to the 3 minus 2, which is going to be 3, 2. This combination will give you 3, and then p squared is half squared, and then 1 minus p is 1 half to the 1. So again, it is 3 over 8. And then I'm going to use another page. So PMF of random variable x taking value 3, which is, by definition, it is probability that x takes value exactly 3. It is going to be 3, 3, p to the 3, 1 minus p to the 3 minus 3, which is 3, combination 3 is going to give you 1, and then 1 half to the 3, and then 1 half to the 0 is going to give you 1 over 8. So we have got PMF. Now my question was to find CDF. To find, I'm going to use, I don't know which color you like, I'm going to use purple. Okay, so to find CDF, which is denoted with f, uppercase f sub x, as a function x, lowercase x. We have to find the probability of the event x less than or equals x. This is important for all values of x taking from the entire real life. Okay? So it's not only limited to the range of values that we have here. Okay? It is actually x can take any value from the real life. So first, let's draw that real line. So you have this real line, and then x can take any value. Let's put 0 right here. So this is your infinity, and this is your negative. So x can take any value in this range. So I want to find the CDF of this random variable x that can take any value from this real line. So how that CDF will look like. So first, let's see, if x less than 0, x is strictly less than 0. So this is your 0, 0. X is strictly less than 0. So in that case, your CDF of random variable x taking value x is, by definition, it it is probability that x takes value less than or equals x. Now here lowercase x means the number of heads. So my condition here is x less than 0. So what will be the corresponding set of outcomes? If x is strictly less than 0, so can number of heads become negative? Can number of heads become negative?
No.
No, it's completely empty set, so it's a null set. So it's null set, so probability of this null event is 0. So we now know, actually I'm going to redraw. So this is my f sub x, and x can take any value from negative infinity to positive infinity, and I am going to use orange color to represent this CDF. When x is strictly less than 0, if this is 0, if x is strictly less than 0, it is going to be 0 all the way, but not including 0, guys. So this is where I'm going to introduce new, introduce new symbol. All the way to 0, but not including 0, because it is strictly less than 0. So that's where the new notation will come. So, and you will see in many authors have used many different notation, but what I am going to use is following. So because it is 0 for all values of x less than 0, so for all values of x less than 0 but not including 0, so that's why I have a little circle here, little circle, very important. I have little circle here that indicates that this f of x is 0 but not at 0. So this is where the difference is. And another new mathematical term will come right from this circle with hollow. So circle with hollow means that f of x is 0 all the way from negative infinity to 0 but not infinity. Now change the condition. If 0 less than or equals x less than 1. So now we are going to go from 0 to 1. From 0 to, let's say this is 1. So this is 1. What is my CDF? CDF of this random variable x taking value x. Now by definition it is probability that x takes value less than or equals x. Now look, so this condition means x can take any value from negative infinity to positive infinity, but we already know that negative infinity to 0 all the way to 0 will not give me anything, 0. Now x can be in between this range. So 0 is included but not including 1. So in other words, you can say it is probability that what is the outcome? X can take value of what?
0.
Just 0, that's it. And 0 corresponds to
180.
0 corresponds to just TTT, right?
Yeah.
So number of heads is 0. So this is outcome. And then I'm getting back to your answer. So it is basically probability that it is x equals 0, which is basically, what is the probability that x equals 0, which is, by definition, it is PMF of random variable x taking value 0, which is what we found right here, 1 8. So 1 8. Now guys, look. Now we look at this range. So we go from 0, when x equals 0, it is, CDF is 1 8. So 1 8, let's call this 1 8 right here. So this is 1 8. Okay? And here I'm going to put field dot. Field dot means that at x equals 0, it is f of x is not 0, it is 1 over 1 8. You guys understood? At x equals 0, it is 1 8. And it will go all the way, to 1, but not including 1. You see that? So make sure you know this notation. So it will go all the way to 1, but not including 1. Now I'm going to change the condition. So here I have if 1 less than or equals x less than 2. So I want to find CDF of random variable x taking value x, which is by definition probability that x less than or equals x, and it is going to be probability that you can write in terms of outcomes as well. It is probability that your x equals 0 and actually you can write it, you can have one more line. So here, probability that you have given x equals 0 union x equals 1. That's all you can think of, because number of heads cannot be fractional. It could be either 0 or 1, because the condition we have right here. So now, because these are mutually exclusive events, so you can just add them up. Probability that x equals 0 plus probability that x equals 1, which is basically PMF of random variable x taking value 0 plus PMF of random variable x taking value 1, which is basically PMF of random variable x taking value 0 is 1 8 plus PMF of random variable x taking value 1 is 3. So it is 4 8, it is going to be half. So now when x equals 1, it is CDF is 1 half. So let's say 1 half is right here. So it goes all the way to 1 half, and then you have a field dot right here. So which means that at x equals 1, you have CDF is 1 half, not 1 8. And x equals 1 all the way to 2, let's say this is 2, all the way to 2, not including 2. So that's why I have this circle with the half. Now we are going to change the condition. Okay, guys, remember, keep in mind that we have to cover this entire real line because we are working with CDF. We have to cover this entire real line. So we cover everything from negative infinity all the way to 0 and all the way to 2 basically, not including 2. But we are going to include 2 now. So if 2 less than or equals x less than 3. So in that case, the PMF CDF of random variable x taking value x, which is by definition, it is probability that x less than or equals x, which is probability that x equals 0 plus probability that x equals 1, and you can include probability that x equals 2, but not including 0. So that's all This is basically PMF of random variable x taking value 0 plus PMF of random variable x taking value 1 plus PMF of random variable x taking value 2 is going to be 1 8 plus 3 8 plus 3 8. So it is going to be, what it is, 7 8. So now you go back to your plot. You go back to your plot. So 2 to 3 all the way. So from here, when x equals 2, so this is going to be 7 8. When x equals 2, it is 7 8, not 1 half. So that's why I have filled dot, and it goes all the way to 3, but not including 3. So let's say this is 3, not including 3. Now, the final condition. So if I have x greater than or equal, so you include 3. Now x can take any value from 3 to infinity. So if you include this condition, you have f sub x taking value x, which is probability that x less than or equals x, which can take probability that x equals 0 plus probability that x equals 1 plus probability that x equals 2 plus probability that x equals 3, which is, by definition, these are simply PMF of random variable x taking value 0 plus PMF of random variable x taking value 1 plus PMF of random variable x taking value 2 plus PMF of random variable x taking value 3. Now you substitute all the values that you found already. So PMF of random variable x taking value 0 plus 1 over 8 plus PMF of random variable x taking.
You mean less than or equal to?
No, greater than or equal to. So less than 3 we got. Okay? And
Well, why would you include the probability of 0 if x is greater than 2? And 1 and 2?
oh, that's a good question. That's another. That's a very good question. Okay.
You're saying that 1 is greater than.
So x greater than or equals 3. But when we write the CDF of random variable x taking value x, this CDF is going to take everything from negative infinity all the way to x. Now you consider x equals 3. Okay? When you consider x equals 3, forget about it. When you consider x equals 3, what do you see? So it is basically probability, you find probability that x less than or equals 3. So you take all the values starting from negative infinity all the way to 3. That is by definition the CDF. Okay? So when you include 3, now this x includes all the way from negative infinity to 0 is included, right? Because probability, number of x could be 0, right? So x equals 0 is included here, and not 0.5 here because it's a discrete random variable. Okay? So x equals 1 is included here, x equals 2 is included here, and x equals 3 is included here.
Yeah, well, I understand why if it's less than, I don't understand if you're saying x is, I guess I'm just confused on why we switched to greater than 3 when other reasons were in.
Less than, right?
Yeah.
Yeah. So the reason I switched to greater than or equals 3 is I cannot put less than infinity anymore. So I have to cover. I covered negative infinity all the way to 3. Now I just want to cover the rest
Yeah.
from 3 to like positive infinity. And I have to cover this random variable straight from negative infinity all the way to positive infinity. And that's the definition of the CDF. Okay? So without, if you do not cover all the way from negative infinity to positive infinity, that means you did not define the CDF properly. Okay? And that is the result. So you can you can still write like that. So this doesn't matter if 3 less than or equals x less than so let's say that also yeah that is also correct, okay, because you are actually covering everything that actually matches with the previous condition, but here I just wrote it this way because there is a problem with infinity, okay. So here negative less than infinity means x is finite, okay, less than, but we did not define that x is finite. We do not know that x is finite. So by definition, this x is basically for all values of x from negative infinity to positive. So we simply cannot write this negative less than infinity just to denote that it is finite. All what we can say that x can take any value from the delta. Okay? Or what I can say that x can take any value from this delta. So that could include that, negative infinity. So that is the reason we do not write it like that. We stick to the definition of the serial, and if we write it as x greater than or equals 3, it is we are on the safe side. Make sense? So we have 1 8 and then we have 3 8 plus this is 3 8 plus this is 1 8. What it is, guys?
Just one.
Simply 1. Okay. So now you go to come to this point. So when x equals 3, it is simply 1. So guys, based on this example, I'm going to go through the properties of this serial and make sure you know this numerical example. That way, the property, it's going to be easier to visualize the property. So when x equals 3, it is 1, and it is going to stay 1 all the way to the infinity. You guys understood? Yes.
Wait, but if you told me before, wouldn't nothing happen because you can't toss the coin anymore?
Yeah, if you toss a coin, let's say 3 times, your random experiment that you toss a coin 3 times. Now, let's say what if you have x greater than or equals 3, which means that x can take 4 as well, right?
Yeah.
That's what you were saying.
Yeah.
Which means the number of heads equals 4, right?
Yeah.
But you are tossing a coin 3 times, so number of heads equals 4 is going to be an impossible number.
Yeah.
So that will give you probability 0. So if you keep adding, which is, so let's say EMF of random variable x taking value 4 is going to be 0.
Oh, I don't know. Oh, I see.
Yeah.
Okay.
You just keep adding, but that addition will not give you anything because those will be impossible events and they will be 0. Okay? So you can just keep adding like plus 0, plus 0, plus 0, plus 0, you can keep adding. But relevant numbers are 0, 1, 2, 3, that's all. Clear? All right. So this is going to be 1. So now, do you see your serial? It is from, I'm going to use, I don't know, 3. Let's see what's orange. So it is from here, negative infinity all the way to 0, but when x equals 0, it is going to be 1. When x equals 1, it is going to be 2, 1 half. When x equals 2, it is going to be 7, 8. When x equals 3, it is going to be 1, and after that it is going to be
Yeah.
1. All the way, okay? So when you define CDF, make sure you have this plot from negative infinity to positive infinity. So in the exam, if I ask you to find CDF, you can show me this graph, or you can directly write it in the form mathematically as well. So therefore, in concise form, the CDF, you can write it. Therefore, the CDF of binomial random variable x in concise form. So you can just write concisely, you can write f sub x taking value x is going to be. So this is another notation, guys. So make sure you write it down. This is another notation. F sub x is going to be 0 if x less than 0, and it is 1 8 if 0 less than or equals x less than 1, and it is going to be 1 half if 1 less than or equals x less than 2, and it is 7 8 if 2 less than or equals x less than 3, and it is going to be 1 if x greater than or equals 3. That way you cover the entire real line. So this is also correct. Okay? You can show me graphically, or you can show me mathematically as such. So, but if you show graphically, then there is another advantage, where if I ask you to find the probability, then it is easier to find the probability from the graph. And I will show you in a moment. So this is another way. Now I would like to introduce another terminologies. Here, guys, you see, here you have sharp vertical lines. These are called jumps. These are called jumps. In mathematics, these are called jumps. And these jumps will actually give you the probability at this point. Now, if I ask you what is the probability, let's say, probability of x equals 2, if you are given this CDF, you can find the probability straight from CDF. So probability at x equals 2 is basically magnitude of this jump. Is the magnitude of the jump at x equals 2. So what is the magnitude of jump at x equals 2? It is basically, look guys, very important, f sub x at 2 minus f sub x at 2, look, minus, I'm giving minus as the superscript. What it means that f sub x at 2 is going to be 7 8. F sub x 2 minus is going to be 1. So that's what it means. It is like 2 minus delta for small delta very epsilon. So which is 7 8 minus 1/2 is going to be 3. So you can directly find the probability from the CDF. If you are given CDF, you can directly find the probability from the CDF, which is basically, if it is a discrete random variable, CDF is going to look like this, and then you can find the probability at a particular point, which is the magnitude. Now the other thing is this CDF, the plot that you see is basically, it is a continuous function. It is a continuous function. Even though it looks like a staircase, but it is a continuous function. Why it is continuous function? You can actually see that at 0, even though it looks like there is a jump, but at 0, the value is basically 1/8, not 0. So at 0 minus, you can see that it is 0. So this CDF is basically a continuous function. Now let's go through some properties. But before I go through properties, so you can implement CDF as such. Guys, here there is a different way of computing CDF. This is a different way of computing CDF, but you can actually compute CDF directly using dot CDF, np dot CDF. No, sorry, not np dot CDF. So instead of this, you can directly use binom dot CDF. So binom dot CDF will give you CDF values. But instead of binom dot CDF, you can also use numpy. Numpy dot cumulative sum. And why I'm using cumulative sum, you guys actually can figure out why I'm using cumulative sum. Right from the theory. Do you see? From if x less than 0, you have 0. If x is between 0 and 1, not including 1, it's basically cumulative sum all the way from negative infinity to 1, not including 1, right? So here you are basically using cumulative sum, 0, 1, and here you are using basically cumulative sum 0, 1, 2. Here you are using cumulative sum 0, 1, 2, 3. Do you see that? So you can directly use binom.cdf, or you can use numpy package. So what this piece of Python code is doing, you are importing numpy, and just for plotting purpose, you are including pyplot, and then you are importing like binom module from this package, the statistics, sci-fi statistics, the statistics package. So this is your user-defined function. You are defining a function here, compute underscore CDF. You can do any other name. Okay, user-defined function. Number of coin tosses. So n equals 3 is the number of coin tosses. P is the success probability, and then x value is basically range from 0 to 3. Because n equals 3, this a range function will give you a number from 0 to whatever the number here minus 1. So because we have n plus 1, that's why it will give you a number of 0, 1. So PMF values, you can directly use binom.pmf values. You give range. So this is your range as an input. And then you have n, which is the total number of trials, and you have success probability. Okay. So these are the 3 parameters that this binomial.pmf method, binom.pmf method. So therefore, this PMF value will be how many? So it will give you an array. So first one is going to be PMF of random variable x taking value 0. Second one, PMF of random variable x taking value 2. Third one, PMF of random variable x taking value 2. Fourth one, PMF of random variable x taking value 2. So you will have an array of 4 values. So that will be your PMF. And then CDF values, you can use np dot cum sum, or instead of np dot cum sum, you can use binom dot cdf. Binom dot cdf also. And then you guys are junior at this point, so you guys already know what is a step function, right? Step function, u x is basically 1 if x greater than or equal 0, and it is 0 if x less than 0. Okay, this is basically a step function. So this is 1 and this is 0. So you can actually use the step function, and I'm going to use why this step function is utilized, because there is an example here that actually I linked it to this Python code. So use step function to actually plot the CDF, and CDF is a continuous function that actually can utilize the step function to plot. And I'm going to show you why this step function is used. There's an example. So you give x level, y level ticks, and then y ticks, and then you have a grid. These are just for plotting purpose, and you have a for loop to actually print the CMF values. Now your Python program actually starts from this line. And in Python, guys, some of you are struggling because you are actually placing this code with same indentation as this def. So in Python, this indentation matters, guys. If you do not indent properly, your Python code will not give you correct result. Here, your Python code is going to start executing right from here, because see the indentation here. And then you are calling this function, compute underscore CDF, and then without any parameter, it will go right. Now it's going to execute all these lines and then print it. So that's the Python implementation of the example that we went through. Now, the properties of CDF. Look, 0 less than or equals f of x less than or equals 1. Why it is that? It's right here. So f of x cannot be more than 1, f of x cannot be less than 0. F of x cannot be more than 1, f of x cannot be less than 0. So for all random variables that you know. Here we solved random variable, binomial random variable, but for all random variable you can think of, f of x has to be between 0 and 1. When x goes to infinity, your f of x has to be 1. Similarly, when x goes to negative infinity, limit x goes to negative infinity, then your f of x has to be 0. If you have a less than b, then your f of a, fxa has to be less than fxb, because b is larger than a, so therefore their corresponding CDF should follow this inequality. And therefore f of x is a non-decreasing function. It will keep growing, but it will not come down. So the slope is going to be positive all the time. Okay. So therefore f of x is a non-decreasing function, and f of x is continuous from right. So this is what another important. See, what does it mean, continuous from right? Look at the previous example. What does that mean? This f of x is continuous from right. I'm going to use a red color. So f of x is continuous from right. Look, guys, very important. You just understand, then it should be fine. Continuous from right means 1, let's say x equals 1, and we have plus. What it means is that limit your epsilon tends to 0, and then f sub x, and you have 1 plus epsilon. So for a very small epsilon, f x 1 plus epsilon is going to be exactly f sub x. So that's what it means. It is continuous form, right? So you get 1 plus epsilon is same exactly, is exactly the same as f sub x 1. So which means that if you want to evaluate right here, it is going to be, it's very, for a very small, it is going to be exactly 1. That's what it means, that it is continuous from right. And continuous from right, that is the reason positive. But the opposite is not true. Properties of intervals and single values of x. If you have this inequality, a less than x less than or equals b, so it is going to be, you take the CDF of b minus CDF of a for all b greater than or equals to. If you want to find what is the probability exactly at x equals b, if you want to find, you just get the jump, magnitude of the jump. It is basically the magnitude of jump at point b. So this is exactly the example. I went to one example. What is the probability that x equals to, given the CDF, you just find the CDF at x equals to minus your CDF of x 2 minus, which means that it is CDF of x equals to minus the CDF of limit epsilon goes to infinity, it is CDF of 2 minus epsilon. 2 minus epsilon. So that is nothing but the jump at point x equals. If you want to find what is the probability that what is the probability of x greater than x, then you just find what is 1 minus epsilon, because this guy will give you probability that x greater than x. So because this guy, this CDF includes x greater than or equals x, therefore 1 minus probability that x greater than or equals x will give you probability that x greater than. So this guy is basically probability that x less than or equals x. So probability that x less than or equals x, 1 minus probability that x less than or equals x, it will give you probability that x greater than x. Now there is another condition that is important, is if you have probability that a less than or equals x less than or equals b, should be probability you find f of x at point b, and then you take for an epsilon positive, you take f of x a minus epsilon. So this is the formula. You can use directly this formula. We are going to, let's go through this example. In this example, we are going to utilize the previous properties. So here, in this example, let x be the number of heads in 3 tosses of a fair coin. Find CDF of x, a solution. Okay, let x be the number of heads in 3 tosses of a fair coin. Find CDF of x. We already found CDF, right? For the same experiment, right? Yes.
Yeah, what's the difference between the capital X and like the lowercase x? Can you explain that real quick?
So this uppercase x means indicates that it is a random variable.
Okay.
Okay, and this lowercase x means that random variable takes value of this lowercase x. Okay, where this lowercase x can take any value. So solution, CDF of random variable x, which is f sub x, found in the previous example. And we can just write it one more time for convenience. It is 0 if x less than 0. It is 1 if 0 less than or equals x less than 1. It is 1 half if 1 less than or equals x less than 2. It is 7 8 if 2 less than or equals x less than 3. And it is 1 if x greater than 1. So mathematically we did that and we have the jump plot as well. So we already found what is f sub x. Now use f sub x to find the probability of the event. So probability of event A is probability that we have 1 less than x less than or equals to. Guys, do you see that it is, you can think of this as A, this is B. Now look at the previous. See, A less than x less than or equals B. Don't get confused with this inequality. It's A strictly less than x less than or equals. So you can directly use this formula. So which is basically f sub x 2 minus f sub x 1. Now can you tell me what is f sub x 2? So f sub x 2 is going to be, it is actually 7 8. And f sub x 1, it is basically minus 1 half. Right from here, from mathematical definition. So it is actually 3 8. So this is the solution, this is the probability of A. Probability of B which is basically 0.5 less than or equals x less than 2.5. What is the probability that 0.5 less than or equals x less than 2.5? Okay, so here, now look at 0.5 all the way to 2.5, not including 2.5. Go to that graph. So 0.5 is right here. 0.5 is right here, all the way to 2.5. Here, we want to find the probability of x taking in this range. Guys, because it is 0.5, so any values around this 0.5 is going to remain the same, right? Right? Any value between this 0.5 is going to remain the same because it is continuous. And 2.5, any values, because less than or equals like plus epsilon, minus epsilon doesn't matter. Any value around this 2.5 is going to remain the same because of this flatness. So therefore, what we write here is since f sub x is continuous from right, I explained what is continuous from right. What does continuous from right mean? At x equals 0.5 and x equals 2.5. It doesn't matter if you put less than or equals or less than equals here. So you can simply write probability that 0.5 less than or equals x less than 2.5 is exactly the same as probability because of this condition. Probability that 0.5, you can put less than it, doesn't matter, because it's continuous around 0.5. Yes? And you can put less than or equal to 2.5 because of the continuous property, continuous property. So now it is, you can simply write f sub x, like A and B condition that is done, f sub x 2.5 minus f sub x 0.5. So f sub x 2.5 was 2.5 is 7/8 and 0.5 is 1/8. So it is 3/4. So probability of B is 3/4. We need to find probability of C that will utilize this formula as well. So that is a bit more challenging. That's the solve. Let's find probability of C in our next class.